Thanks for sticking around. So we have the last session of the day. I know everyone's probably a little bit tired, but I appreciate folks sticking around. So for this session, I'm going to be talking about specifically that platform profiler tool and how you can use it to optimize system configurations for Intel Optane DC persistent memory. So many of the faces here obviously were in the previous session, so you know what Platform Profiler is. But there'll be a brief introduction to Platform Profiler, and I'll also do a live demo. I'm learning how to use this microphone, and during the live demo it might be a bit of a challenge, but bear with me, and we'll teach you a lot about how to use Platform Profiler. So when it comes to Optane DC persistent memory, there's what we see as 3 steps to characterizing and optimizing the workload. The first step is characterize the workload. What is my workload doing? How is it using the hardware on the system? What are the resource bottlenecks? Those sort of things are very important to understand before you go into the next steps. After you've characterized the workload, you want to figure out what is the right size platform to run on. Right? A lot of times, you can save your engineers a lot of work tuning the performance if you just pick the right platform ahead of time. If you understand the resource needs of the workload and you get a platform to meet those needs, then you can save a lot of engineering time from the software engineers. What configuration changes should I make? What sort of platform is best for my workload? Finally, you want to start optimizing the workload from a software perspective. How do I get the best performance out of the platform that I've chosen? How do I analyze my workloads to figure out how they're performing? And what changes do I need to make to the software in order to get the best performance on my platform? This slide is giving you a matrix of several of the ways that you can use our tools, and it's broken down by whether you have an application focus or a system focus, and whether you want just a quick snapshot of your application or of your performance, or you want an in-depth analysis. I'm not going to talk about every single thing in this slide, but I will talk about this bottom right-hand corner here. This is what we're talking about today. System-wide profiling that can run for a long time. That's what this L means here. That's what Platform Profiler is good at. If you want a tiny little profile of 1 second for your application, that's not what Platform Profiler is good at. But if you want to analyze a workload that's running for several minutes or several hours and figure out a general idea of the performance, that is what Platform Profiler is very good at doing. So I talked briefly about Platform Profiler in the context of our suitability analysis in the previous talk, but this slide is more of a generic overview. Platform Profiler is not really targeted at application developers. Platform Profiler doesn't tell you the lines of source code that you're having performance issues with. Platform Profiler is targeted at people like infrastructure architects, software architects, people that are making decisions about which platform to buy based on which workloads are running in their data center or on their cloud. And they want to analyze the usage of the platforms that they're in charge of. It collects system-wide data. It does not collect application-specific data. And it provides things like topology diagrams, explaining how the system is configured. You'd be amazed how many times people have run Platform Profiler. They thought they had one configuration, and they found out they had a different one. Right? They thought all of their SSDs were distributed evenly between the 2 sockets. But they ran this and they found that all of the drives were attached to only one socket. Or they thought all of the DRAM DIMMs were populated evenly throughout the system. But the person who built the system didn't do that. They populated the DRAM DIMMs in a different way. And you don't know that until you run a tool like this. So you might make assumptions about your platform, but until you run this, you can't be sure. The types of performance metrics that we collect are very low overhead. If you've ever done performance profiling, you know that it's very important to not change the performance of the application while profiling it. If your performance monitor is high overhead, then the results that you collect are no good, right? You have to be very low overhead. We use OS information and hardware performance counters to collect this data, and that's how we can be very low overhead. I mentioned minutes to hours for the capture, and the way that the data is displayed is actually via a RESTful API and a web browser. So you can share the information via a web browser with anyone that has the URL that you give access to it. Here we can see a few screenshots of the type of information we collect. IOPS from the disks, queue depth from the disks. This is all related to disks and memory, but we have a lot of information about CPU and other pieces of hardware as well. So let's do a little bit of a tour of Platform Profiler. And before I do that, I just want to explain how Platform Profiler works. Platform Profiler has two pieces, a data collector and an analysis piece. The data collector is extremely lightweight, a command line tool that can be deployed on any system very easily. You launch the data collector on that system, you profile as long as you want, you stop the profile, and it generates a result. You can then put that result on another machine, maybe a server that's shared amongst your company or anywhere that you want, and that is the machine where the analysis is hosted. And on that server machine, the visualization is handled, and that's the machine that users can connect to via a web API and look at the data. So similar to our other VTune tool, you don't have to do the data analysis on the same machine where you ran the profile. Nobody wants to be launching GUIs and having users doing data analysis on a machine that's deployed in the cloud. Right? It's important that data analysis can be done offline on a different machine. So let's take a look at a Platform Profiler result, and I'll see if this is manageable while using the microphone. Excuse me. So here you can see I'm just in a Chrome browser. Right? I collected platform data, I launched a Platform Profiler server, and I added the result to it. In this case, the server is just running on localhost. It's just running on my laptop. But you can imagine this server is running in your data center somewhere, or in your office, and all of your users or all of your performance engineers upload their data there, and then they can share it all. And in order to view it, they just go to this URL, they open up the result, and they're looking at the data in a web browser without needing to install anything on their laptop. So you can see here, for this analysis result, we have some information here about the machine where it was run, when it was run, what was the architecture, what was the configuration of the machine, etc. It's important that this is always maintained with the result, because the performance data that you're looking at is always going to be relative to what you see here. If you see a little Atom core, you shouldn't expect high performance. If you see an expensive server core, that's going to change what performance numbers you're expecting to see. The default view that you'll get is called the overview, and you can change that. You can drill down to a socket view or a core view if you want to go very low level. You can look at metrics just related to memory or disk, UPI if you're concerned with communication between the sockets, I/O for more disk metrics, and you can also customize the views. Here we're looking at a workload that was obviously very hungry for memory. You can see that over time, this long-running workload peaked out at 100% memory consumption very often, right? It's broken down by the used memory allocated by the application, the page cache that the operating system is maintaining, and how much memory is free on the system. And it appears that there's some sort of cycle that's going on here, right? The memory spikes and then it dips a little bit, and then it spikes and it dips a little bit. And all of the timelines that we see in Platform Profiler can be correlated together. So if we scroll down a little bit, we'll see some performance metrics. If anyone here is familiar with the top-down methodology, you may not be, but this is one methodology for identifying the bottleneck in a CPU pipeline. The pipeline on our Intel x86 processors has many stages as the instructions move through them, and there's many different points in that pipeline where you can get a bottleneck. You can get a bottleneck in the front end. You can get a bottleneck in the back end. You could be bottlenecked by memory or core, or you could have bad speculation where a bunch of branches are being mispredicted. The best case is you have a high percentage of retiring instructions that are moving through the pipeline efficiently. But Platform Profiler is giving you an overtime view of what your bottleneck in the x86 core is, right? So at any given time, you have a certain efficiency in that core, and you can see over time how that's changing for your workload. If we go down, we can see more metrics around memory throughput, and it appears to have the same kind of cycle, right? It goes up, it goes down. We also want to look at CPU metrics. How much CPU utilization do you have? This is going to be very important for performance, right? And we have disk metrics as well. The nice thing about Platform Profiler is everything is tied together. So if I see something I'm interested in, let's say we think one cycle is interesting. You can drag across that area of interest, and it will filter all of the graphs just on that area. So now you can see here we've just zoomed in on a small set of time. It gives you a better resolution, and all of the metrics that we're seeing are for that smaller resolution. And you can go much smaller than that as well. And now if I go to another view, let's say I want to look at memory-specific metrics, you'll actually see that on the memory view, it's maintained the view, or the filter that I was interested in. So I still have that little region that I've selected that I'm interested in, and now I can see the metrics on the memory view. So whether I want to see memory utilization, page faults that we mentioned are very important for applications that are swapping data in and out of disks because they're running out of memory, and maybe Optane DC could be useful for them. Pages allocated, pages freed. This workload is not particularly interesting from a networking perspective, but we also have metrics around network and disk I/O. If we look at the I/O viewpoint, we can see some of those metrics just to give you an idea of the types of things that can be collected by Platform Profiler. So now we're seeing some of the devices that are attached to our system. We're seeing disk throughput, and there's network statistics as well. It's hard for me to see exactly what's displayed way over there. But this tool is included with VTune. So if you download VTune for free and install Platform Profiler, you can deploy it on your machines. And from there, you'll be able to analyze the applications just like I've been showing here. So let's swap back over to the presentation. And you can see the model, right? The data that I was showing there was not collected on my laptop. The data that I was showing there was collected on a Linux machine in our lab at Intel. I uploaded it to a server that happened to be running on my laptop. And now, if that was a web server with an actual IP address, I could give you that URL, and you could look at that data from your laptop on the hotel Wi-Fi, right? So it's a really neat usage model that doesn't require you to share all of this large data with anyone that wants to look at it. All you share with them is a URL, and as long as they have a browser, they can do data analysis as well. So really quickly, I think most of the people were in my last talk, but if you're not familiar with Optane DC persistent memory, this is a new memory technology that has attributes of DRAM. It can be used in a mode called memory mode, where you are extending the system memory and it's transparent to the users, so everyone can see a large amount of memory without needing to change their applications. And it also has NAND SSD attributes, which you can obviously tell from this word persistent here. DRAM is not persistent. When your machine loses power, whatever's in DRAM is gone, right? When you start it back up again, you have to start from scratch. This technology is persistent. So if you've got a database and you're putting things in Optane DC persistent memory, when it power cycles, that data might still be there, as long as you've done your persistent memory programming correctly. And that can be a huge performance boost if you need to warm up that database again after a power cycle, for example. Again, the Optane DC persistent memory can be programmed in 2 different modes. Currently, if you don't have Optane DC, your machine is just this legacy over here, where all you have is DRAM. If you get Optane DC persistent memory, you can have it in memory mode, which just extends the system memory naturally. You plug in the Optane DC persistent memory, and all of the applications see that large memory, and when they do a malloc, it can go there. When they do a free, it's freed automatically, and there's nothing that the developer needs to do. App Direct mode has the opportunity to give more performance and also persistence if the developers want to spend some time manually choosing which objects to put in DRAM and which objects to put in persistent memory. And they can do that either with custom APIs or using a library like PMDK, for example. And there is a mixed mode supported as well. If you have a lot of Optane DC persistent memory and you want to use some of it as App Direct and some of it as memory mode, you can do that. Some of the metrics you want to look for when determining how to configure your system for the workloads that you have running today are memory and storage behavior. Do you have a large memory consumption? If you're getting close to 100%, then that may be an opportunity to add more memory, and maybe Optane DC is the type of memory you want to choose. It's cheaper per gigabyte than DRAM, and if your bottleneck is not necessarily memory latency, then it may be a good choice. Memory utilization is this top one here. Page faults can give you an idea of whether you're swapping to disk. Memory read-write ratios. The latencies to Optane DC for writes are generally longer than the latencies for reads, so understanding your read-write ratios is very important. Memory throughput and disk activity, particularly if you have storage applications, right, where they need to use disks and they're bottlenecked by disk activity, Optane DC persistent memory can help. It's much faster than many of the disk-based solutions that are available today. Some of the metrics that impact performance that you want to look for are CPU utilization. One very important concept to understand for performance tuning at all is how important CPU utilization is, right? So CPU utilization is a key indicator for whether you have available for every person. Another configuration is the 221 configuration. In this case, what we've done is we've removed one of the Optane DC persistent memory DIMMs, and one of the channels has only a DRAM DIMM associated with it. You can go even lower to a 211 configuration. Now we've got 3 DRAM DIMMs and a single Optane DIMM, or even a 111 configuration that I'll talk about on a future slide. And with each configuration, you're trading something off, right? So as you remove Optane DC persistent memory DIMMs, you're trading off DDR bandwidth, because remember, in this case, your Optane DC persistent memory is seen as DRAM in memory mode for board real estate, right? You're not populating as many slots, but which is cheaper, or maybe that's the platform you have available, but you're trading something off. If we look here, for example, a fully populated system is going to have lower memory utilization than a system for, in this case, a 111 system that has one Optane DC persistent memory DIMM, a couple of DRAM DIMMs. you obviously have much less memory available to the system, and the same workload, in this case, is seeing maybe 40% memory utilization as opposed to, I don't know, 15% memory utilization, right? But the concept that's important to understand here is, when I characterized my workload, how much memory did I need? Did I need 1.5 terabytes of memory, or is 512 gigabytes of memory sufficient? You can get that information before you invest in the next platform, and you can choose a configuration accordingly. Another metric that's affected by the configuration is memory throughput. Here, I've populated every channel with memory. And as I mentioned earlier, Platform Profiler can give you a per channel memory view. It's only shown as a sliver here, but you can see that every channel is being used in this configuration. In this case, I haven't been able to populate every channel with DRAM, or in this case actually DC persistent memory, which is in memory mode, which represents the system memory. So only 2 channels are showing me persistent memory traffic, because I didn't populate every channel. And understanding whether throughput is important. To get peak throughput, you want every channel populated. You want everything available to you on the platform. But if your workloads are not sensitive to memory bandwidth or memory throughput, then certain configurations may be more reasonable for the platform that you're looking to invest in. And then finally, optimizing the application or the set of workloads that are running on your platform. For this one, Platform Profiler can help, and our other VTune analysis tools can help as well. The performance metrics you want to look at when identifying performance bottlenecks are things like memory throughput, read and write throughput. Again, I don't want to hammer on it, but understanding the read and write behavior of your application is also important. Every memory access is not the same. Some are faster than others. So understanding the ratio of your reads and writes. Persistent versus volatile needs. How much persistent memory do you need versus how much volatile memory do you need? If you don't need persistence, then there's memory mode, for example, as an option. If persistence is essential, then you need to use one of the persistent APIs. Memory latency, DRAM activity as well. How much performance are you getting out of the persistent memory with the latencies once you have the platform running in memory mode, for example, and what are the cache hits and misses when you configure your platform in memory mode. In memory mode, as I mentioned, the persistent memory is completely transparent to the user, and the way that's done is by turning the DRAM into a cache and using the persistent memory as the system memory. So here we're actually talking about cache hits and misses for the DRAM as cache in memory mode. So just to summarize, the first thing you want to do is characterize your workload. Understand what are the bottlenecks, what are the important performance metrics for your workload, what's the platform you're currently running on, and what are the things that you need to be interested in. Once you've characterized your workload, then you want to start thinking about what is the right platform for this workload. Is it currently running out of memory? Is it currently bottlenecked by disk or something in the core? And I could use more cores more than I could use more memory, right? What is the right platform for this workload based on what I found out when I characterized it? After you figure out what platform you think you want, then you want to start optimizing the workload. Run the workload, look at the important performance metrics for optimizing a workload, and use tools that are available to you to optimize that workload. Whether it's VTune Amplifier, Platform Profiler, some other tool that can help you optimize your workload, that's what you want to do after you've figured out what the right platform is based on the characterization that you've done. And for many of these workloads, as we've shown before, Optane DC persistent memory can be very helpful, particularly if you need more memory, if you have performance issues related to disk or storage, or you need persistence and currently you're using disks because that's the only technology available to you. The final slide gives you some information on the tools. These tools are available for free. You can download and install them today, run them in your data center, profile your workloads, generate the same graphs that I've just shown you, and start doing some characterization, some right sizing of the platform, and some optimization. Also, one thing I'll mention, we have a hands-on tutorial tomorrow in the afternoon. So if you want to attend that, we'll be walking through some usages of VTune and Platform Profiler, and you'll be able to look at some results that we've already generated, understand what we're looking for, and do some optimizations. So with that, I've got my colleague Yang here. If you have any questions, feel free to ask them in Chinese. If you're more comfortable, he can help translate. Otherwise, I'll be around the conference, and I look forward to talking to everyone. Any questions?
Maybe Collector needs to install the customer environment. And how's the OS support? As you know, the customer environment may die. So is there any kind of a concern or suggestion to make sure that tools can be installed well?
Yeah, so the question about OS support, we support the major distributions of Linux. We support Windows. The key element that's required for our tools is the ability to collect PMU counters. So every Intel chip has registers on it that count performance events, and we have a driver that collects those events. And there's some certain kernel configurations that are required to expose those events. But as long as you don't have some crazy customized kernel that has locked everything down and we can't access those events, our collector should be able to run there. We've validated it on a lot of different Linux distributions. And if you, for some reason, can't get our collector to run, we're very open to feedback, and it may be a simple tweak either in our collector or in your kernel to make sure that the performance collectors can run. Yeah, so there's some kernel configurations in the kernel that are required to expose those PMUs. And worst case scenario, you have a kernel that doesn't have those PMUs exposed, and you can change the configuration and rebuild the kernel. But that's going to depend on the kernel. Yeah, so it really is all about whether the PMUs are available to our collector. Yeah. And if there's a specific kernel, then we can test on it, but we can't test on every kernel, so it's hard for us to know exactly which kernels are supported. Any other questions? Okay.
Platform Profiler 可以搜集的时间支持的比较长。如果你用 VTune 的话，可能是做那种比较细密度的技能分析，它可以帮你定位到源码呀、汇编啊，采集的时间可能是几秒或者几分钟之类的东西。那 Platform Profiler 的话，它可以跑很长时间，就是几个小时或者几天的这个场景下面，来测你的整个系统、整个平台的这么一个系统分析数据。因为它各个就是不同的场景下用不同的工具。不会很大，不会很大。我们采过大概好几个小时的话，可能也有1-2个 G 吧。因为它的数据你可以压缩的很也还是我们是还是可以接受的，我们车里。它采集的是实际的，它那个 workload 的那个数据不会采集。对，就是比如说，当前的系统的这个 memory 的那个带宽，I/O 有多少，对吧？然后这些跑多少条 instruction， 然后这些性能相关的一些数据，它可以采集下来。但是你 workload 本身我们没有办法。好吧，要是没有什么问题的话，那明天的话，我们有 Suda， 是我们在做，我们是 monitor 这一块，针对 PMPK， 的一个专家，然后他会讲一些fundamental的，就是怎么去通过工具去 monitoring 这个跟 PMDK 相关的一些这个系统数据的。刚才那位中心的同事建议你每天可以听一下，应该对你有用。好，要是没什么其他问题的话，谢谢大家。然后刚才讲了这个待会儿有抽奖，是在这个会议室。好，谢谢大家，谢谢大家。